Hello, dear students of the third prep grade, and welcome to a new episode of our program. It's time for mathematics, and on this episode, we'll be discussing and explaining a new lesson of algebra. Actually, it's lesson 1 of Unit 2, Ratio and Proportion, with our teacher of mathematics, Mr. Ashraf Helmi, expert of mathematics at the Ministry of Education. Hello, Mr. Ashraf, and welcome to the program.
Hi.
So, Mr. Ashraf, I know that this lesson has been or had been studied actually in primary 5. All right, so we're having it again in prep 3. So
Yes.
why is that?
Yes, actually, some new rules are added to third prep for ratio and proportion. And these new rules will help me to solve a new applications for ratio and proportion and deal with the ratio proportion in another way, maybe some life applications.
But it's a big gap actually from
Yes.
primary 5 to prep 3.
Yes, actually it's a big gap, but you know, in prep 1 and prep 2 we the Ministry of Education put some items, important items, and they built on this items another items, so maybe it's time, maybe, and because we can't put ratio and proportion maybe in prep 1 or prep 2 because an important item students should passing through in these 2 years.
So it's an old lesson in new clothing.
Yes.
All right.
Yes.
So let us begin by having or talking about the old lesson, all right, and discuss the definition of ratio and proportion.
Okay, let's work on this and discussing the ratio of its meaning is a comparison between two numbers which have the same maybe units or the same type. So, for example, if I have the ratio between the length of two persons, one of them of length 1.5 meters, and the length of the other one is 100 centimeter, and I ask you to find the simplification of this ratio. So the first thing that we have to do is change the type of one of them, so both of them will have the same type. We have here 1.5 meter, and changing 1.5 meter to centimeter, the answer will be 150 centimeters. And this is 100 centimeters. So to simplify this, I'm going to divide both sides by 10, so it's 15 to 10. Simplifying again, divide by 5, the answer it will be 3 to 2. So this is the ratio, a simple kind of ratio. We can't find actually the ratio of 2 terms. We have ratio of 3 terms. For example, if we have
very simple rules so far for them.
Yes, yes. So this is the first part of our lesson. As you see, we are going to make the thing we call it warming up, a small training for the students before going on the game.
To link the old to the new.
Yes, of course. So let's remember something about the ratio of 3 terms. For example, if we have 25 to 15 to 10. And I want to find simplification of this ratio of 3 terms, so I'm going to divide all of them, divide by 5, so this is 5 to 3 to 2. Okay, the new thing that we have to know about ratio is when we have a ratio of 2 terms, for example, 5 to 3, we can write it in another way as 5 over 3. And of course, we knew before that 5 over 3 could be written in a new form as, for example, 50 over 30. I multiplied both sides by 10s. So when I multiply both sides of the ratio by 10, we have a new ratio with the same answer of this ratio, 50 over 30. Or if I multiply by 2, for example, so the answer is 10 over 6, which is the same thing as 5 over 3. And the main rule that we have to remember here, that if we multiply both sides of the ratio by a number which is not equal 0, it gives me the same ratio. But if we add a number to both sides of the ratio except 0, for example, we have a new ratio and they are not equal. So we can't say, for example, 5 over 3, and we add 2 to both sides, it will be here 7 over 5, so this answer is completely wrong. So if we add 2 to both sides of ratio, it doesn't mean that we have the same ratio here. But if you multiply 2 by the 2 sides of the ratio, it will have another ratio which they are equal. Okay, let's remember now what we have here about proportion. So for proportion, and the main name of the proportion, it's an equality of 2 ratios or more. So for example here, if we have 3 over 4 equals 15 over 20. Actually, this is a proportion of 2 ratios. The ratio between 3 to 4, we can write it as here, 3 over 4. So we have 3 over to 4, which is the same as 15 to 20. So this is a proportion, an equality of 2 ratios or more. I can say that this is equals, for example, 30 to 40. So I have a proportion of 3 parts. Okay, let's remember something about proportion we knew before that. If I have a proportion 3 to 4, which is the same as 15 to 20, and we said before we can write it as 3 over 4 is the same as 15 over 20. We have names for this proportion. And for the first number here, 3, so this is the first number or the first proportion. So this is the first proportion. And for 4, which is the second proportion. And for 15, which is the third proportion. And for 20, which is the fourth proportion. So we have 4 quantities and they are proportion. A new technique of writing this, so we can write it as 3, 4, 15, and 20. And we say something like this in 5th primary as these 4 numbers are proportion. Because 3 over 4 is the same as 15 over 20. Okay, let's write another example here on our page. For example,
still revising the old rules
yes.
of ratios and ratio and proportion that they studied in elementary 5.
Yes. So, for example, when I ask you, is 5, 7, 10, 20, is it a proportion? If I want to ask this question, so is this number form a proportion or not? So
5, 7, 10, 20?
yes. So we have to arrange them.
Yeah.
So 5 over 7, and we have 10 over 20. So is this ratio equal to this ratio? Actually, 10 over 20 is the same as half. So, and half is not equal to 5 over 7. So actually, this is not a proportion. But 5, 7, 10, 14. So when I ask you, is this a proportion?
5 over 10, 7 over 14.
5 over 7, yes. And it's the same as 10 over 14, of course, because 10 over 14, the simplification of 10 over 14 is 5 over 7. If you divide by 2 up and down, the answer it will be 5 over 7. So this is a proportion.
What about if we have it like 5 over 10 and 7 over 14?
Actually, this arrangement is very important for the students. So when I write 5, 7, 10, 14, as we said before, this is the first proportion. And this one is the second proportion. This is the third proportion.
So we have to do it in order.
Yes, and this is the fourth one. So the name of this proportion is arranged as long as these numbers are arranged in this way.
Okay.
Now, another thing we have to know about proportion, and actually we knew it before, but we are going to write it in a new clothes, as you said before. For example, if we have the ratio between 2 numbers x and y, the ratio between these 2 numbers...
We're going to add something new here.
Yes. If the ratio between 2 numbers x and y is 3 to 4, the most common mistake in this part that some students says that x equals 3 and y it will be 4. And this is a very common mistake in some students. And the right answer here that x it's 3 times a factor m, and of course y it's 4 times a factor m, and this factor doesn't equal 0. As long as x over y equals 3 over 4, maybe x is 30 and y is 40. So 30 over 40 is the same as 3 over 4. So we can say that x has one value which is 3 and y has one value which is 4. Maybe x is 6 and y is 8, so the ratio between 6 over 8 it will be 3 over 4. So I have to write it in this form. So x equals 3 times a factor, I'm going to name it as m, and y equals 4 times a factor, and of course this factor is not equal 0. This is a very important thing we have to know about proportion, and we can work on some exercises on our pupil book. So let's go on the pupil book.
Yeah, all right. So now we're going to have some new exercises, something related to the new lesson, something that we added to. You know, you had this lesson already before, but we're having more ideas, more rules related to it. So let's go to page 23. Am I right?
Yes.
Page 23. And we have the first exercise here, which says two integer numbers. The ratio between them is 3 to 7. And if subtracted 5 from each term, the ratio between each of them becomes 1 to 3. So find the two numbers, and you can see this on the lab here. Yes.
Okay, for the first one, we have two integer numbers. The ratio between them is 3 to 7, so I have to write an assumption here. And my assumption here that I'm going to name the first number, so let the first number be x. I'm going to name it as x. And let the second number be y. And as you see in the question, the ratio between x to y is 3 to 7. So the ratio between these two numbers is 3 to 7. It doesn't mean that x is 3 and y is 7, but it means that x equals 3 times a factor m, y equals 7 times a factor m, and this m doesn't equal 0. Now, what we have here is said if we subtracted 5 from each term. So I'm going to subtract 5 from each of these two terms. So I'm going to write here 3m minus 5 over 7m minus 5. And in the question, if I do so, the ratio between each of them becomes 1 to 3. So this, it will be 1 to 3. Okay. Now, for this equation, I'm going to solve a simple equation, 3m minus 5 over 7m minus 5 equals 1 to 3. And to solve such equation, I'm going to use a strategy which we call the cross multiplication strategy. So I'm going to write the equal here. I'm going to multiply 3 by 3m minus 5, so 3, open bracket, 3m minus 5 equals 1 multiplied this proportion 7m minus 5, and the answer of course it will be 7m minus 5. So let's multiply 3 by these two terms. The answer will be 9m minus 15 equals 7m minus 5. And for this equation, I'm going to collect the like terms in one side. So we have 9m and here is 7m. So I'm going to write in this side 9m minus 7m equals, I'm going to collect the like terms in the other side. So we have 15 minus 5. So here we have 2m equals 10. So m equals 5. Actually, we haven't finished the exercise. We got the value of this vector, which is 5. So we have here m equals 5. So we are going to move back again to x and y in this part. So m equals 5, and x is 3m, so I'm going to multiply 3 by 5, so x it will be 15, and y it will be 7 times 5, which is 35. So the two numbers, which their ratios is 3 to 7, is 15 over 35, and these two numbers, if we subtracted 5 from each term of them, of course the ratio it will be 1 over 3. If you want to check your answer, you can do so. And if we subtract 5 from these two numbers, it will be 10 over 30, and the ratio between 10 over 30 is 1 over 3. So you can check your answer in such kind of questions. We have another exercise, which exercise maybe number 2.
Yeah, it says two integer numbers. The ratio between them is 2 to 3. If you add to the first 7 and subtract from the second 12, so the ratio becomes between them becomes 5 to 3. And find again the two numbers. And before we do it, could you tell us the difference between the two exercises 1 and 2?
Actually, in the first exercise, we subtracted 5 from both terms. So we have one number subtracted from the both terms of the ratio. But in the second exercise, we add 7 and subtracted 5, and subtracted, 12 from the second term. So for the first one, we subtracted only one number from the both terms of the ratios. But in the second exercise, we add a number and subtract a new number from the both terms of the ratios. So maybe it's the same, but some students think that we have to subtract the same number by the two terms. And some exercise maybe comes in this way. And to solve this exercise, as we said before, the first thing I have to do, I have to put an assumption. And we have two integer numbers, so we have the first number. I'm going to put an assumption that I'm going to name the first number as x, so let the first number be x, and let the second number be y. And then the question says the ratio between them is 2 to 3. So I'm going to draw here x to y is 2 to 3. Okay. So we have x to y is 2 to 3. And we are going to write here that x, it will be 2 times the factor m, y equals 3 times the factor m. And of course, this factor m doesn't equal 0. So I prepared now my question. I can read now the question to form an equation so I can solve the exercise. We have here, if we add 7 to the first term, and the first term here is 2m, so I'm going to add 7 plus 2m, and subtracted from the second 12. So I'm going to have here, I'm going to subtract from the second 12, so 12 minus, or maybe 3m minus 12. And the answer, of course, it will be 5 over 3. So we have 7 plus 2m over 3m minus 12, and the answer is 5 over 3. A simple cross-multiplication strategy. I'm going to multiply 3 by the first proportion, so 3 times 7 plus 2m equals 5, open bracket, 3m minus 12. Using a distributive property. And when I use the distributive property, I'm going to multiply 3 by 7, which is 21, plus 6m, equals 15m minus 60, as 5 times 12 is 60. And collect the like terms in both sides. So I'm going to collect the like terms here. So 15m minus 6m. And here's 21 plus 60. And of course, in this part, it's 9m equals 81. So m, it will be 9. When you got m, it doesn't mean that you have finished. because I do need the two integer numbers and I have the factor m. So back again to this part. And for this part in the question, x equals 2m and y equals 3m. So all what I have to do, replacing m by 9. So I'm going to find the value of x. So x equals 2 times 9, and the answer is 18. And y equals 3 times 9, and the answer is 27. These are the two numbers that we have here. So this is exercise number 2.
Shall we move to exercise 3?
Okay,
so,
of course.
We are doing now exercise 3, page 23. And it says, find the number that if subtracted thrice means, of course, 3 times,
Yes.
Of it, from each of the terms of ratio 49/69, the ratio becomes 2/3. So I'm gonna read it out once again. Find the number that if subtracted thrice of it from each of the 2 terms of ratio 49/69, the ratio becomes 2/3.
In this exercise, we have to find one number. And for the last 2 exercises, we have to find 2 numbers. So we don't have x and y here. So we have one assumption, which is let the number be x. So if we subtracted the thrice of it from each of these 2 terms, so we have, I'm going to write it here. So I'm going to write here, I have a ratio here, which is 49/69. So I'm going to subtract thrice of it from 49/69. So I'm going to maximize the fraction here. I'm going to make minus 3x, and here is minus another 3x. And the answer actually becomes 2/3. So this is an equation, a simple equation for maybe second or first prep level. So I can do, and again, the cross multiplication strategy. So 3, open bracket, 49 minus 3x equals 2 times 69 minus 3x. Okay, I'm going to use the distributive property. So 3 times 49, and 3 times 9, of course, it's 27, and carry up 2, and 3 times 4, it's 12, plus 2, which is 14, which is 147. And 3 times 3, it's 9, so we have here minus 9x equals 2 times 69. So 2 times 9, it's 18, and carry up 1. And 2 times 6 is 12, plus 1, the answer is 13. Minus 2 times 3, or it's negative 3, actually, it's 6x. Now we are going to work on collecting the like terms. So we have 147 minus 138 equals 9x minus 6x equals. And for 9x minus 6x, the answer is 3x. And here for 147 minus 138, and the answer is 9. And 3x equals 9, so of course x will be 3. So the number that I'm going to subtract, it's triple from both terms, 49 and 69, and the answer, it will be 2/3 is 3. And if you want to check your answer, all what you have to do is replacing x here by 3 and calculate this part, and the answer, of course, should be 2/3.
So do students get grades on each of these steps?
Of course, for each one of these steps, maybe if they have, of course, a mistake in the second step or the third step, all the next steps will be wrong, but the strategy that they're gonna use on these steps, it has marks, because when you see some students use a strategy of collecting the like terms in both sides, so he knew how to solve something like this. And maybe
so what if the steps are okay, are fine, but the final answer is not correct?
Of course, we have marks for using the strategy.
Yeah, they're not gonna lose much.
No, because the marks are divided on the strategies and the calculations. So if we lose the marks on the calculations, you will not use the marks on the strategies. And of course, if you lose marks on the strategies, and you're going to use all the marks because the strategies is wrong and the answers or the calculations are wrong. So you're going to lose all your marks. So it's very important to know the strategy that you are going to use and use the right strategy in the right time.
Yeah, I have another question here. Are there any alternative solutions to solve these problems?
Of course, there are many ways to solve such questions, but in this part of ratio and proportion, we are going to use the most simple way for students. But maybe you can use a strategy of solving something like this. Maybe a new strategy. Maybe it's the last strategy in ratio and proportion. Maybe not in this episode.
But the one you use is the easiest.
Of course.
Yeah.
Yes. A new strategy that we are gonna know maybe for next episode or maybe the next one. How can we solve something like this in the most easiest way? And some students would say, how do I don't know something like this before? Why you didn't tell me something like this before? And this is the steps that you have to learn when you work on a kid and you want to learn him how to move. Of course, he will not run, but the first thing you are going to move in a small steps. Maybe you're going to use a big steps, then he's going to run.
Yeah. Okay, so now let us move to exercise 4. Again, we are still page 23, and it says find the number which, if its square is added to each of the two terms of the ratio 7 to 11, it becomes 4 to 5. Let's read it out once again. Find the number which, if its square is added to each of the two terms of the ratio 7 to 11, it becomes 4 to 5. How difficult is this one?
The main difference between number 3 and number 4 that we have the square of this number. So the equation that will be formed now is a second degree equation, and for the equations in number 3 it's a first degree equation. And for the second degree equation we have two solutions, but in the first degree equation we have one solution. So in this exercise, find the number, and the first assumption that we said before is let the number be x, or choose any name for the number. And it says here if its square is added to both terms of the ratio 7 to 11. So I'm going to add x squared plus 7, for this is the first term, and add x squared to 11, and this ratio becomes how many you said in your exercise?
It becomes 4 to 5.
So this equals 4 over 5. As you see, this is a second degree equation, and to solve such second degree equation, the first strategy, as we said before, cross multiplication strategy. So 5 open bracket x power 2 plus 7 equals 4 times x power 2 plus 11. The second strategy we have to do now is using the distributive property. So we have here 5x squared plus 35 equals 4x squared plus 44. The third strategy now, collecting the like terms in both sides. So we have 5x squared minus 4x squared equals 44 minus 35. And for 5x squared minus 4x squared, two like terms. So I'm going to subtract the coefficients. 5 minus 4, and the answer is 1. So we have 1x squared equals 44 minus 35, which is 9. And as long as x power 2 equals 9, so we have two solutions for x. And the two solutions here are, we have either x equals 3 or x equals negative 3. And as we said before, a second degree equation, so we have two answers here for the second degree equation. The first one is 3, and the second one is negative 3. And if you want to check your answer, all what you have to do to replacing x in the equation and check if the answer will be 4 over 5, as we said here.
All right. In the exam, how many questions could be related to this lesson, ratio and proportion?
It's the second unit in algebra. And in algebra, we have 3 units. The first unit is functions, and the second unit is ratio and proportion, and the third one is statistics. And you can say 30% of questions will be focus on such unit. And
30%?
Yes, 30% of question, as long as we have 3 units in algebra.
8%.
Yes, of course, of course. And it's a simple, actually, unit. We have many life applications in this unit. I think that students in third prep will enjoy working in this. When we move on exercises, we are going to see some life applications, and most of the students ask you, I don't know why I study something like this. I don't know why studying proportion now. Where is the life application? Something like this. But in this unit, maybe at the end of this unit, we have many life applications on ratio and proportion.
Yeah. Could you again, once again, remind us of the difference now between the old and the new?
Okay.
Tell us more about the old rules of elementary 5 and the new rules of prep 3.
Okay. Let's divide this page here. And for the old one, as we said before, and if we have a proportion of 3 numbers, for example, 3, 4, 9, and 12. And for 5th primary, these 4 numbers are proportion. But in 3rd prep, I will not write these numbers as, or not write this proportion in numbers. I'm going to write them as A, B, C, D are proportion. And maybe I'm going to give you one of these proportion. For example, when I said 5, B, 10, 20 are proportion. I want you to find the missing proportion, which is the second proportion. And the second proportion we have here is B. And if we want to find the value of B, you have to arrange this proportion. So 5 over B equals 10 over 20. Using a simple cross multiplication, so B equals 5 times 20 over 10. And of course, B, it will be 10. Okay, another thing we have to know about proportion, which is, for example, if A, B, C, and D are proportion. So let's arrange this in a fraction. So of course, A over B equals C over D. And we said before that if we have A over B equals C over D, this maybe means A equals C times M, and B equals D times M, and this M doesn't equal 0. Or we can write this in another way. So we can write that A equals B times M, and C equals D times M, and this M doesn't equal 0. And of course, this M in this rule is completely different than this M in this rule. This is what we have new in this level for third prep, that we have new rules for proportion. A over B equals C over D. And it's the same as A equals C times a factor, and B equals D times a factor, and this factor doesn't equal M. Or you can write as A equals B times the factor, C equals D times the same factor, and this factor doesn't equal 0.
All right, do we have any new ideas related to the new lesson?
Yes.
Or the new ratio, the new proportion that we've added for this lesson?
Of course. Let's write an example here about this. If we say before that 3, 4, 6, and 8 are proportions, so 3 over 4 equals 6 over 8. So if we want to write another ratios, and these ratios equal to these two ratios, I'm going to multiply 3 by a number, or maybe divide 6 and 8 by a number. The new thing that we have in third prep, if we add the antecedent of these two proportions, so we have 3 plus 6, the answer is 9. And if we add here 4 and 8, the answer, it will be 12. So the ratio between 9 and 12 is the same as the ratio between 6 and 8 is the same as the ratio between 3 and 4. And of course, if we subtract 3 and 6, this is the antecedent of this ratios. So 3 minus 6, the answer, it will be -3. And subtract the consequent, which are 4 and 8. 4 minus 8, the answer is -4. So the ratio between -3 to -4 is the same as 3 over 4. So we can write this new rule as, if we have A over B, which is the same as C over D, this is a proportion of 4 quantities. A, B, C, and D are proportion. So this proportion may be equal A plus C over B plus D. Or it will be the same as A minus C over B minus D. And if I want to generalize this rule, I'm going to write it in another way. So if we have 4 proportional number, A, B, C, and D, so A over B is the same as C over D. So these two ratios equals, is the same as M1, which is a factor multiplied by A, plus M2 multiplied by this factor multiplied by C over, and of course if I multiplied A by M1, I'm going to multiply B by M, the same factor, which is M1, plus M2 multiplied by D, which is the factor that I multiplied by C. And of course, don't forget that M1 doesn't equal 0, M2 doesn't equal 0. And if we want to see some exercises on this, I can write an exercise to show you how can we face something like this.
More difficult ones?
No.
Not
the
more
first
difficult.
start should be the most easiest one.
Yeah.
So
But let us say with newer ideas.
Of course, of course. So if we have, for example, these two ratios and they are equal, if we have x over 3 equals y over 5 equals, and I wrote here x plus y and here a space. So what should I write in this space? So as you see here in the numerator, we add x and y, x plus y here. So I'm going to add 3 and 5. So the answer here, it will be 8. Okay, what about if I wrote here x over 3 equals y over 5, and for example I wrote here 7. So what should I write up here? As you see, we have 3 and 5, and of course 3 plus 5 doesn't equal 7, and of course 5 minus 3, it doesn't equal 7. So I have to work on these two numbers to form 7. You have to multiply one of them by a factor, or maybe both of them by a factor, then add or subtract to find 7. There are many ways to do something like this, and some students like this kind of exercise because it's a mental exercise. So 5, if we multiply it, for example, by 2, the answer is 10. And 10 minus 3, it gives me 7. So what I have to do now to multiply, if I multiply 2 down, I'm going to multiply 2 up here. So we have 2y minus x. This is the answer of the numerator. So 2y minus x in the numerator and 7 in the denominator. So this ratio is the same as x over 3, and the same as y over 5. So this ratio maybe equals one of these two ratios. Okay, what about if I wrote something like this? X over 3 equals y over 5 equals, I'm going to write here down 11, for example. So what should I write up here? How can I find 11 from 5 and 3? We have two numbers, 5 and 3. You have to multiply one of them or maybe both of them by a factor, then add or subtract these two consecutive to find 11. Okay, so if we multiply 3 here by 2, the answer is 6. Then you add it to 5, so the answer, of course, will be 11. So I'm going to multiply up here by 2. So 2x, as I multiplied here by 3, I'm going to multiply up by 2. So 2x plus y, this is what I'm going to write here. So this ratio, 2x plus y over 11, equals one of these ratio, maybe this one, as long as I follow the rule, or the new rule of proportion. Okay, let's have another exercise on this. If we have, for example, x over 3 equals y over 5 equals z over 2. And here I'm going to write down, for example, 8. What should I write up here? In this exercise, we have many answers could be written here.
How to start thinking about such an exercise?
We said before that we are going to look to this number 8, and we have to look for this 8 by multiplying one of these numbers by a factor, then maybe use adding or subtracting to form 8. So the most easiest way to form 8 is, for example, multiplying 2 by 4. So if I multiply 2 here by 4, and I'm going to multiply up here by 4. So all what I have to write here is 4z. And this ratio is equal to one of these two ratios, which is z over 2. Another answer for this exercise maybe could be written here. So we have x over 3 equals y over 5 equals z over 2 equals, and here is 8. So maybe if we add 3 and 5 gives me 8. So x plus y, this is what I'm going to write here. So as you see in this exercise, there are two answers could be written in this exercise, and maybe some students now they are watching us and they say, Mr. Yasser, Mr. Ashraf, we can find 8 by multiplying blah by blah and blah blah blah, and find this 8 by their equations and write their equations here. So we say that such kind of exercises as an open-minded exercise. So many answers could be put in this exercise.
Can we have a more difficult one?
Why want to do this? Why
a more complicated idea?
Why you wanna do this with our students? This is the first episode in this exercise. Okay.
Yeah, because usually when you solve the hardest, you are ready to solve the easier.
Okay. Maybe we can work on some exercises on our pupil book.
Yeah.
We have, for example, exercise here, page, a drill, and this drill is on page 29. And for page 29, we are going to work on a simple, let me do this please, simple one. Exercise number 5.
Yeah.
So we said before it's page 29.
29.
Yes.
All right.
So exercise number 5, page 29. We have here a given: if x over 3 equals y over 4 equals z over 5, then prove that 2y minus z over 3x minus 2y plus z equals 1 over 2. There are two ways actually to solve such exercise. The first way is to find the values of x, y, and z. And how can I do so? That these three equal ratios, we have a proportion of 3 parts. This is equals m, and this m, of course, doesn't equal 0. They are all equal. So I made these three ratios equals m. So x equals 3 times m, so this is 3m. And y equals 4 over m, 4m, I'm sorry. And z equals 5m. So we have the values of x, y, and z. Now, let's work on the left-hand side and simplify it to find 1 over 2. So for the left-hand side, we have 2y, 2 multiplied by 4m, minus z, which is 5m, over 3x, which is 3 multiplied by 3m, minus 2y, which is 2 times 4m, plus 5m. Okay, 2 times 4m, which is 8m, minus 5m, the answer is 3m. And down, 3 times 3m, which is 9m, minus 8m, plus 5m, the answer is 6m. And simplify this, so the answer is 1 over 2. And this is the first way we can do this exercise. We use a simple rule we studied before that find the values of x, y, and z. Okay, another way to solve this exercise is
the same one.
Yes, the same exercise by the new rules that we knew before. That we are going to write the proof in a new way. The proof here, it says, prove that 2y minus z over 3x minus 2y plus z equals half. So I can write it as prove that 2y minus z over 1 equals 3x minus 2y plus z over 2. So this proportion is the same as the proportion that's written in your book, that 2y minus z over 3x minus 2y plus z equals 1 over 2. So to do something like this, I'm going to work on the left-hand side and the right-hand side as we said before. So we have the ratios that it's given in the question. X over 3 equals y over 4 equals z over 5. We have three ratios. So to form 2y minus z for the left-hand side, so I'm going to multiply the first ratio by 2 up and down, so 2y, and subtract it from z. And I'm going to do the same in the denominator, so 2 multiplied by 4, and for 2 multiplied by 4 minus 5. And the answer it will be 2y minus z over 3. And this is for the left-hand side. And for the right-hand side, as you see here, we have 3x minus 2y plus z. So 3x minus 2y plus z. I multiplied x by 3 here and x by 3 up, so I'm going to multiply down by 3, so the answer is 9 minus 2 times y. So I multiplied 2 up here, so I'm going to multiply 2 down, so which is 8 plus z, and it's 5 here. So the answer will be 3x minus 2y plus z over 6. And of course, these two ratios will be equal because I used the last one rule, which is I made some calculations up and down, and these two ratios should be equal. So 2y minus z over 3 is the same as 3x minus 2y plus z over 6. And I can write this in a new way as 2y minus z over 3x minus 2y plus z down here, and the answer it will be 3 over 6, which is half, and this is what we have in this exercise.
All right, I don't think we have much time left, so in brief, I'd like you to just sum up what we've had on this episode.
Okay, the first thing we knew in this episode that if we have
2 minutes left,
a proportion A over B equals C over D. So the first one here is the first proportion, this is the second proportion, the third, and this is the fourth one. And another thing we knew that A equals B times a factor, and C equals D times a factor, and this factor doesn't equal 0. And if we have A over B equals, for example, 3 over 4, so A equals 3 times a factor m, and b equals 4 times the factor, and this factor doesn't equal 0. And for example, if we have A over B equals C over D, we knew that we can write this in a new way, that A, B, C, D is a proportion. This is what we knew today about ratio and proportion.
All right, do you have anything else to add before we wrap up this episode?
It's very important for students to solve all the exercises in the pupil book.
Yeah.
And this is the main source for them. And I think if they did all the exercises in the tests and the exercises in the general exercise at the last 3 or 4 pages, and this is enough to get the full mark, inshallah.
Inshallah, and I guess we've already had enough applications related to this lesson on this episode.
Okay.
Right?
Yes.
We've had enough applications already. We've had a lot, and I think it's also not a very hard lesson, a lesson that is related to what they had before in elementary 5. So I'm sure that you all found this lesson interesting and easy. I'd like to thank you very much, Mr. Ashraf Helmi, for being with us and for this beautiful explanation of this lesson, ratio and properties. This is, or proportion. This is a lesson we've had during this episode. Thank you very much, Mr. Ashraf. And that brings us to the end of this episode, dear students of the 3rd prep grade. I guess we've had lots of exercises on this lesson, ratio and proportion. That is lesson 1 of unit 2. Inshallah, we'll be meeting you again on our next episode next week. And don't forget to join our Facebook group, Madrasa ala al-Hawa I'dadi. This is our Facebook group, Madrasa ala al-Hawa I'dadi. So try to join this group and contact us and tell us about your suggestions, your questions, whatever you want to tell us about. Just let us do through this Facebook group. I hope you found this lesson interesting and easy and useful. And until we meet you again next week, inshallah, wish you all the best. Goodbye.